We are on lesson 4, following a book on Precalculus by Larson. We're on chapter 1, section 2, Introduction to Functions. All right, so going down here to the definition of a function f from a set A to a set B is a relation that assigns each element x to the set A exactly one element y in the set B. The set A is the domain or the set of inputs in the set of the function f, and the set B contains the range or the set of outputs. So I like to go over, we got x, we have y. They also like to call x the domain, and y is the range. Here they're calling x the input, and then y is the output. You put an x in and you get a y out. X is also called independent, and y is dependent. So down here below, they got a picture of what makes a function. It says, to help understand this definition, look at a function that relates the time of day to the temperature. So the number 1, or so 1 p.m., it's got a temperature of 9 degrees, and at 2 p.m., it's got a temperature of 13. Each one of these times for the day has one output for the temperature. Each one just goes to one number. So none of these numbers repeat. There's no repeat of one of these numbers going to two different numbers. 4 doesn't go to 13 and go to 12. Each one of them is used only one time. The y here was used twice, and that's okay. You can use a y more than once, but to make it a function, the x never repeats. That's why you hear a lot about the vertical line test. If you have a function, we'll make a parabola here. As long as you can draw a vertical line and it only goes through the function one time, it's a function because the x's don't repeat. If by chance you turn it to the side, then it's not a function, because when you draw a vertical line, the x repeats. Like maybe this is the number 4, 2, and that's the number 4, negative 2, but the x repeats. So it's okay for a y to repeat. Here, up here, we have a y repeating. Like we'll say this is maybe 2, 4, and maybe this is negative 2, positive 4. But it's okay for the y to repeat. It's just the x never repeats to make it a function. So it passes a vertical line test, then it's a function. Yes, it's a function. This was a function because the x's didn't repeat. Again, it's okay for the y's to repeat. Okay, on to the back here. They have some characteristics of a function from a set, if you'd like to read them. And then down below, we have some questions. They want to know whether these are functions or not. So number 8, is that a function? Well, the number negative 1 goes to 3 and the negative 1 goes to 4. So it repeats. So no, it's not a function. X repeated. X went to two different places. Negative 1 went to 3 and negative 1 went to 4. Over here, Alabama goes to one place. Everybody just goes to one y output. So yes, that's a function. The x's aren't used more than one time to go a different place. Number 16, the same idea again. Are these functions? The very first one here, letter A, is not a function because the letter C is there twice for x. The C for the input gives 2 for an output, and for an input it gives 3. You can't have it. Every time the C goes in, you have to have the same outputs for it to be a function. The next one's okay. A, B, C, we don't see the letter repeat at all. 1, 0, 2, 3. So that one's okay too. The x's didn't repeat. So this one's not a function. And yes, those two are functions. Okay, and then on the next page, it wants you to testing for functions represented algebraically. Determine whether the equation represents y as a function of x. The key on this, I looked it up, I looked in the book, I looked online. There's like not a particular way you do it. Overall, what you're doing is you're solving it for y. So we'll say the method here is you solve for y. If you only have one equation when solved for y, then it's a function. All right, so the very first one, solving this one for y, I'm going to move the 1 over, so that makes x minus 1 equals y squared. And so the y isn't really quite by itself. There's two y's. We want there just to be one y, so we're going to take the square root of both sides. Remember, when you take the square root, you get two answers. So y equals plus or minus the square root of x minus 1. So it makes two different equations. So no, it's not a function. No, not a function. Because you have two different equations. And you've shown it algebraically that you've got two different equations. And if you put it in your graphing calculator here, we got, let's see, the square root of x minus 1. And then we got the negative square root of x minus 1. You'll see it makes a sideways parabola when you put the two pieces together. So, like we talked about, it's going to fail the vertical line test. And it's because it's two equations. Okay, the next one. So note, when there's a little 2 on the y, it's not going to be a function because you're going to have two equations. This one, I can just look at it and I know it's a function. So this one's not a function because the y is to the second. Anything to the second for a y is not going to be a function. This one's definitely a function. The y is not to the second. There's nothing crazy going on with it. It's going to be a line. Solving it for y, we got x minus 5 equals negative y. So y is by itself, and then divide everything by negative 1. So it gives you negative x plus 5 equals y. So it's an equation of a line. It's going through the number 5. And it's got a negative slope of negative 1 over 1. So it's just a line. Of course, it's a function. It's only going to have one line go through it when you do the vertical line test. Number 28, whenever you see y trapped inside the absolute values bars, it's also not going to be a function. Because, going to suppose land here, if you got the absolute value of x equals 4, x could either be negative 4 or it could be positive 4. There's two different answers for it. Either one of them will give you the absolute value of x equals a number 4. So you've got two equations. Likewise here, y is either equal to this, 3 minus 2x, or y is equal to negative of the quantity 3 minus 2x, which is negative 3 plus 2x. And when you graph that, it makes something that's not a function. We could put it in the calculator here so you can see it. So we got 3 minus 2x. And then we've got negative 3 plus 2x. So it's not going to pass the vertical line test. Okay, number 54. So this one's also a no. And again, the big clue is that y is trapped inside the absolute value symbol. Here the problem was y was to the second. But on both of them, we had more than one equation when we solve for y. We only want one equation when solved for y. Okay, number 54. Finding the inputs that have outputs of 0. Find all the values of x such that f of x is equal to 0. Recall f of x is y. So when it says f of x, it means the letter y. So y is equal to 0. So if f of x is equal to 0, what is the value of x? We'll put 0 in for f of x, because they said f of x is 0. So 0 equals 5x plus 1. Move the 1 over, so it's negative 1 equals 5x. So negative 1/5 equals x. On the back, we're going to figure out the difference quotient. Find the difference quotient and simplify your answers. For 86, we have f of x equals x to the third plus x. For f of x plus h minus f of x over h when h is not equal to 0. All right, so you're picking up x plus h and you're plugging it in for x because this is the input for the letter x. So put in for x. So x plus h to the third plus x plus h. and then minus f of x. And f of x is, again, x cubed plus x. Don't forget parentheses. You need to subtract the whole quantity. So minus the quantity f of x. And then all over h. All right, so let's go down below and do x plus h to the third, and then we'll bring the answer back up here. We'll do it over here to the side. So x plus h to the third. So x times x, x squared, and then you got xh, and then we got hx again, and then h times h is h squared. So the first two multiplied together make x squared plus 2hx plus h squared, and then times x plus h still right here. And so multiplying that together, I'm going to do the second times the first. So I'm going to multiply everything by the x going that way. So everybody gets one more x. So that makes x cubed plus 2hx squared plus h squared x, and then everything's times h. So give everybody an h. So that's hx squared then, and then plus 2h squared x. And then h times h squared is h to the third. So adding it up, we got x to the third plus 3hx squared. There's a 1 here. 1 plus 2, 3. And then 1 plus 2 here is 3 more h squared x plus h to the third. So take that then and plug it in for up here, x plus h to the third. So we have x to the third plus 3h x squared plus 3h squared x plus x to the third, and then it's still plus x plus h, and then minus, so you multiply that negative across there, distribute it across, so minus x to the third and minus x over h. So the x to the third's gone, the x is gone, yeah, there it is, the x is gone. We have plus x and a minus x, and we're left with then 3h x squared plus 3h squared x plus x to the third plus h divided by h. So everything gets divided by h when it's on the bottom, so divide everything by h. So that h is gone, so it's 3x squared, and then instead of 2 you're going to have 1h there, and then that's 2 h's. And then h divided by h is the number 1. So the answer to the whole thing then is 3x squared plus 3hx plus h squared plus 1. All right. So I'll see you for lesson 5.